Hey everybody, I know we have a fairly lengthy homework due soon, so what I wanted to do is I wanted to do some of those with you and for you. Okay, again, more explanations are always good. Also, I know that we have some people who are going to be missing some class, so I just wanted to talk through some stuff. All right, so we have section 3.2 where we're dealing with the three trig functions and also radian measures, so I'll kind of skip around and do a little bit of everything. All right, so down here, if you notice, it looks like we have point Q, which is right down there, and it is, obviously, it has a positive x coordinate because it's over to the right, and it has a negative y coordinate because it's down below the x-axis. Okay, which is what we see there. Point P is, reflected up. It's above that, so it is x comma y. And what we want to know is, what do we know about the sine of theta, which is right down there? Obviously, you see my answer right there. Remember, sine, we're dealing with the opposite divided by the hypotenuse, or the y coordinate divided by the radius. And you have not heard me mention radius at all, but we have eyeballs. We can see that it is 7. So again, it's whatever the y coordinate is divided by 7. Okay, and that's kind of how you have to think of these. All right, there's a logic to it. All right, this next one here, we see that point P is 4, 3, which already we know that point Q is negative 4, 3. Okay, again, when we reflect it back across, the x-coordinate's the opposite and the y-coordinate stays the same. However, we have been asked for the cosine. Okay, now, had we not been given that, we could use the Pythagorean theorem, okay, to figure out, okay, so that's 4, that's 3, 3 squared plus 4 squared equals 5 squared, the radius has to be 5. Okay, we do see that, we do know it. However, we should also get used to the idea that we might not know it, and we might need to figure it out. Okay, and cosine, is the adjacent side divided by the hypotenuse. Again, it is the x-coordinate divided by the radius, which is why I selected option A. So be careful. Again, even though the base of that triangle is 4, it is 4 in the negative x direction. Okay, I'm going to skip down to this one right over here where we've got points P and R, and we are definitely looking for the tangent, and we've had enough conversations to know that tangent not only is y divided by x, it is also the slope, and that, again, you guys always tell me that is an increasing function, it's an increasing line, okay, and we know those have a positive slope. Okay, so is it 12 over 5 or 5 over 12? It's 12 over 5. It's y over x. It's the change in y over the change in x. Rise over run. Okay? Even if we're talking about point R, which is negative 5 comma negative 12. Okay? All right, we're going up. That was supposed to be a different color. We're going up 24 and over 10. So our slope is 24 over 10, 24 tenths, which can, in fact, be reduced to 12 fifths, which is why I selected option D. Okay. Again, just remember the x-coordinate, that's the horizontal displacement, the amount of units to the right, the, the vertical displacement is the amount of units above the x-axis, okay? And the distance between the origin and that point, whichever one we're looking for, that is always the radius, the hypotenuse, okay? So I'm going to scroll down to some of the good ones, okay? We did one like this in class. I think we just did it with x comma y, okay? But now that we know that point P is 6 comma 8, then that means we know that Q is negative 6 comma 8, and R is negative 6 comma negative 8, and S is 6 comma negative 8. And as soon as you figure those out, you can then do the sine, the cosine, and all that stuff. But quickly, as a reminder, okay, remember our initial ray in standard position is the positive side of the x-axis. And then standard position, what we're doing is we're starting and sweeping through in the counterclockwise direction through quadrant 1, okay? And if we get there, quadrant 2 through quadrant 3 to 4, and if need be, we go back around to quadrants 1, 2, 3, 4, and stuff like that. Careful, I'm pretty sure I heard that physics is the opposite. So just, make sure you know which class you're in when we're talking about standard position and these types of graphs. All right. For number 15 here, okay, in blue here, you'll see that I used a geometric approach to figuring out the y-coordinate of point P. Okay, if we know the slope is negative 3/4, okay, then that means we're going down 3 and over 4. But our P coordinates are negative 8 comma y. Okay, so that means we got to do the whole over 4 2 times, which is the 8 that you see there. Which means we also have to do the down 3 2 times, which is why you see a negative 6 over there. And if we have a right triangle here, okay, well, first things first, that means our y-coordinate has to be 6 if the x is negative 8. Okay, now I did also take an algebraic approach. Okay, if we know that y equals negative 3/4 x, well, we know x. Okay, so notice I substituted that in and I just evaluated it and I got 6 that way. Okay, so it doesn't matter which way you go, we can get that either way. All right, now with part 2, okay, we are dealing with radian measures. Okay, same stuff still applies. Okay, our initial ray is still the positive side of the x-axis there. Okay, and we are still sweeping counterclockwise through quadrant 1 until we hit whichever angle that is that we're looking for, and we're calling it theta. It's theta. Okay, now to get to point P, we are told that that angle measure is pi over 3. Okay, quick reminder to go all the way around the circle. Okay, that's 2 pi, which means half of that is pi. Okay, so pi over 3 is 1/3 of the way to pi. Okay, all right, so that kind of sort of means to get to Q, we're going to get 2/3 of the way to pi. Okay, and what you can really do is you can think of this as we're going all the way to the pi and then backtracking 1/3 of pi, because notice P and Q are reflections, which means if the standard position theta to P is pi over 3, okay, over here is another pi over 3. So we could honestly just do that subtraction and say, okay, pi minus pi over 3, okay, well, that's 3 pi over 3, all right, and we do in fact get 2 pi over 3 to get to Q. Okay, and then in all honesty, I'm just literally going to pretend as if we showed it out again. Here's pi plus another pi over 3. Okay, so hang on. Q is that one. Okay, R is 4 pi over 3. And the green one, green S, again, is the full 2 pi minus a pi over 3, okay, which means that one there is, again, one more pi over 3 added to the blue, so we get 5 pi over 3. Okay, now, similar idea is going on with the next one, only now we're told that theta is pi over 6. Okay, and we generated the unit circle today, or at least the angles in radian measures of the unit circle. So if that's pi over 6, then that right there is 5 pi over 6. Again, a full pi minus one of the pi's over 6. That one right there is a full pi halfway around the circle plus an extra pi over 6. So R is, in fact, 7 pi over 6. That leaves us with just point S, okay? And that right there is pi over 6, negative pi over 6. which means to get to s, we got to go 11 pi over 6. All right, I'm going to scroll down and do some of the other ones here. I like this. You guys are helping me do my own homework as well, because I'm going to post the answers and I'm going to show some of my work. All right, a couple more. We'll do a few of these. Again, there's a bunch of these. All right, so let theta be an angle in standard position whose terminal ray intersects the circle at the origin. Let's see, at point P. If P is in quadrant 2, again, so which of these is in quadrant 2? So we're looking for anything between pi over 2, 1/2 pi, okay, and pi. So we're looking somewhere in that interval, and I see that one works, and that's it, okay. Quadrant 3 for number 5. All right, that one is at the bottom of the circle. Again, it's neither in quadrants 3 or 4, but it's right in between. Pi over 3 is in quadrant 1. There's 5 pi over 4 and 11 pi over 6. We just saw 11 pi over 6 is in quadrant 4. So that one right there is in quadrant 3. Quadrant 4, and I'll stop after a couple more of these. Again, because hopefully you get the idea. Okay, quadrant 4, we're going from 3 pi over 2 to 2 pi. Okay, again, in theory, that could also be negative pi or negative or 0 to negative pi over 2. Okay, there's only one of those that fits in there. So yeah, this is really just trying to get a sense for, what's going on, where do we fit around the unit circle, and that's kind of it. Okay, again, I know we've had a lot of conversations, and some of this has seemed a lot, but there's no reason you guys can't handle this stuff. Okay, again, it is going to take some work. It is going to take some thought. It is going to take some struggle, but it can be done. Okay, hang in there. We will do some cool stuff with these things. At least I think it's cool. All right, peace out, everyone.